In the last section, we looked at addition of whole numbers, and so now what we're going to look at is subtraction of whole numbers and how you can draw them on a number line. So remember, we're still sticking with the whole numbers. Our whole number set is 0 along with all of the positive whole numbers. So we're wanting to subtract whole numbers, meaning that we're not quite ready yet in our evolution of all the math we're going through. We're not quite ready for negative numbers yet, so we're just sticking with whole numbers. So for any two whole numbers, a and b, such that a is greater than or equal to b, we want to make sure that a is bigger than b or equal to b. That way we don't get any negatives. So a minus b is a unique whole number c such that a is equal to b plus c. What's interesting is they define subtraction as addition. So what they're saying is basically a minus b is equal to c. This number that you're starting with, that's called your minuend. The number you're subtracting away, the thing that's being subtracted, is called your subtrahend. So in this case, those should be either the same size or a should be bigger. And then the answer that you get is called the difference. And so these vocabulary words are kind of important, especially the word difference. So minuend is what you start with, subtrahend is what you subtract, and difference is your answer. And every subtraction problem can be rewritten as an addition problem. So if it's written a minus b equals c, you can just go back the other way and think of it as addition. That means if you take c and you add b, you'll end up with a. So we're reading it backwards and changing to an addition problem. So the first examples say, rewrite the following subtraction problems as an equivalent addition problem. So we have 10 minus 3 equals x. And I know you guys know that x is 7. I know that you can figure that out, but that's not the point here. The point is just to rewrite it as an addition problem. So we're going to go backwards. We're going to say x plus 3 would be equal to 10. And that's how you rewrite it as an addition problem. X minus 9 equals 20. We'll go backwards. 20 plus 9 equals x. And there we've written the subtraction problems into addition problems. The reason why this is a good strategy a lot of times is because addition is inherently easier. So if you can change the subtraction problem into an addition problem, it makes it easier to do. All right, so how would we model these on a number line? So we'll run through a few examples here. First one says, David has 5 lollipops and he gave 4 to his friend. How many lollipops does he have? So we're saying, like, how many does he have left? So you want to start by explaining like where the 5 comes from. So David has 5 lollipops. So let me go ahead and put him up here at 5. This is what David has. And then he gave 4 to his friend. So what happens is we start here with the 5, and now we're going to move left because he gave away 4 to his friend. So I'm going to say gave away 4. And if you come up to 5 and then you back up 4, you're going to end up here with your answer at 1. And so the problem that is being modeled right here is 5 take away 4 equals 1. That's the problem that we just modeled. So this red part is the minus 4 part. It's this right here. So 5 minus 4 is 1. So that's how you could draw it on a number line, but you kind of have to explain where all the numbers came from. So we did the 5 here in black, and then I did the 4 in red because he gave them away. The SPCA had 9 dogs on Friday. 2 dogs were adopted on Saturday. 4 dogs were adopted on Sunday. How many dogs are at the SPCA on Monday morning, assuming they didn't get any new ones in? So they had 9 dogs on Friday. So let me start there. This is what they had Friday. 9 dogs. Okay, then on Saturday, 2 dogs were adopted. So from 9, I'm going to go down 2, and that's going to be Saturday. And then on 4 dogs were adopted on Sunday. So from here, I'm going to go down another 4. 1, 2, 3, 4. And then what that tells you is that you end up with 3. And the problem we just solved is 9 minus 2 minus 4 is equal to 3. That's the problem that we just modeled. So we're going to the left when we're subtracting. So how about this last one? Let's see if we can figure out what subtraction problem is being shown. So you've got this little cat, and you can tell what direction the cat is walking by where his head is and where his tail is. So it starts out here at 0, and the cat walks all the way up here to 10. And then for some reason the cat turned around. There's no reasoning with cats. I have a bunch, I should know. So the cat turns around and then it walks back this way. We want to figure out how far back did it walk. Well, it walked from 10 all the way back to 3. So that was a distance of 7. So the cat walked up 10 and then it went back 7 and it ended up here at 3. So the problem that's being shown is 10 minus 7 equals 3. And that 3 again is called the difference. The 7 is the subtrahend, the 10 is the minuend, if you want all the fancy terminology. So that's how you draw subtraction on a number line.